Welcome to this guide on determining the electrical conductivity, or EC, of soil, a vital measurement for agriculture and environmental studies. Let's begin by understanding what soil EC is and why it matters. The primary purpose of measuring EC in aqueous soil extracts is to estimate the total amount of soluble salts present in the soil. EC is essentially a measure of the ability of a salt solution to carry electric current, which happens through the migration of ions under an electric field. In terms of physics, salt solutions, much like metallic conductors, are known to obey Ohm's law. The standard unit of conductivity we use is decisiemens per meter, or DSM-1, which is the reciprocal of resistance measured in Ohm's centimeter inverse. Before we measure the soil sample, we must prepare the necessary reagents and calibrate our EC meter. We prepare the standard 0.01 molar potassium chloride solution by dissolving 0.7456 grams of oven-dried KCl in distilled water and diluting it to 1 liter. This specific 0.01 molar KCl solution provides an electrical conductivity of 1.413 DSM-1 at 25 degrees Celsius. This value is critical for instrument calibration. To calibrate the EC meter, use the standard KCl solution and adjust the conductivity knob until the reading is exactly 1.41 DSM-1. Now that our instrument is calibrated, let's proceed with the EC determination of the soil sample. For the measurement, use the same soil-water suspension that was prepared previously. Crucially, allow the soil particles in the suspension to settle in the beaker for approximately half an hour before taking the reading. Before immersion, be sure to thoroughly rinse the conductivity cell with distilled water to prevent contamination from previous samples. Once rinsed, gently immerse the clean cell into the settled soil suspension. With the cell immersed, measure the electrical conductivity of the given sample directly on the EC meter and record the reading. Let's finalize the process by providing context to the measurement. Based on the measured EC value, you should now comment on the salinity level of the soil and its potential impact on plant growth. Understanding soil EC is crucial for managing soil health and ensuring successful crop yields, especially in areas prone to salinization.